Hello, algebra! Time for our next set of exponent rules. So we have, for our first one here, and just a reminder, we talked about the product rule, the quotient rule, and the power rule. We're starting today off with the power of a product, right? The power of a product. So here's what I mean. You've got 3 times 4 being raised to the third power. Now we know that that would be everything in the parentheses would really be multiplied together 3 times. Another way that you can do it, though, is if you look at your top line here and your last line, what changed about them? Well, this was a 3 to the 1, 4 to the 1, right? And that became 3 to the 3 and 4 to the 3. So basically what we did, to put it in another way, you distributed that exponent, right? So it became 3 to the 1 times 3 and 4 to the 1 times 3. And that's how you got this down here. And we can see that in some of our examples over here, where we had 2x raised to the fourth power, that whole product, and it became 2 to the fourth x to the fourth. And then with this one, where we had abc squared, it became a squared, b squared, c squared. So you can see that. So that's what we're going to practice, all right? That's what we're going to practice. And sometimes it's easiest to have, for example, negative 3 squared and then an x squared. That squared is touching the negative in this case as well, all right? So that means that it would be negative 3 times negative 3, which would be a positive 9, and then x squared. So let's try it with our 4 here. We really have 4 to the 1 times 3 times p to the 1 times 3. So this is really 4 cubed, p cubed. Now with this one, you'll notice it's very similar to our first one, but instead of having negative inside, it's actually on the outside. So this would be a negative, and I'm going to distribute that 2 there. So it'd be 3 squared x squared. So that would be 3 squared is 9, so this would be a negative 9x squared. Now that's a big difference. We've got a positive number and we've got a negative number, and that's huge, right? That's a big difference. So make sure that you're aware of what the exponent is touching. This one, it touched the negative. This one, it didn't. All right, let's try this one next. So for this one, we've got a negative 5t squared raised to the third power. So this is really negative 5 raised to the third power, and then t squared raised to the third power. And you'll notice we have to use that power rule next, right, where this is being raised to a power. So negative 5 times, or to the third power, so it's really negative 5 times negative 5 times negative 5. Negative times negative is a positive, times a negative is a negative. So this would be a negative 125. And then t squared raised to the third power is really t 2 times 3. So this is negative 125 t to the 6th. So let's do some more examples of this. All right. So for this one, we've got the negative just hangs out front, and then we are distributing that 2 squared and then a y squared. 2 squared is really 4, so this becomes negative 4y squared. All right, for this one, we've got negative 2y. All of it is being cubed. So this would be a negative 2 cubed and a y cubed. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. All right, I'm going to slide this up so we can look at some other ones. All right, let's do these two next. So we're going to do our power of a product rule first. So this would be x squared times 4 times y cubed times 4. And then we're going to multiply that by x squared times 4, and then y to the 4th times 4. So this is really x to the 8th, y to the 12th, times x to the 8th, y to the 16th. I'm going to rewrite that so my x's come first because they're alphabetically first. X to the 8th times x to the 8th times y to the 12th times y to the 16th. So x to the 8th 8 plus 8 is 16, and then y to the 12th plus 16 is y to the 28th. All right, for this one, we've got negative u to the negative 5th, v to the 4th, all of that being raised to negative 3. So this is u to the negative 5th times negative 3, and then v to the 4th times negative 3. So negative times negative is a positive, so this is u to the positive 15th, and then a positive times negative is a negative, so this is v to the negative 12th. And we'll learn more about negatives later, but for now, just write it as negative, call it good. All right, so that was the power of a product. We're basically distributing that exponent, right? We're distributing that exponent and then simplifying it from there. The next one we're going to learn about is the power of a quotient, all right? Power of a quotient. And this is basically, again, distributing it, but instead of distributing it across, we have to distribute it to the numerator and the denominator. So for example, in this case, this is really 3 to the 1 and 4 to the 1. This would become 3 to the 1 times 3, and then 4 to the 1 times 3. So this is really 3 cubed over 4 cubed. And we can see up here in our example, when we had 4x over 3y squared, it's really 4x over 3y times 4x over 3y. So that's like having 4x squared over 3y squared. And we can actually do our power of products then, which is what they did down here. So this is another case of basically distributing. All right, so for this one, we are going to have 2x cubed being raised to the third power, and then yz being raised to the third power. And now I'm going to apply, because we've done our power of a quotient, now I'm going to apply our power of a product rule. So this is really 2 cubed times x to 3 times 3 over y cubed z cubed. So this is really 2 to the third power is 8. And then we've got x to the 9th over y cubed z cubed. All right, for this one, we take our numerator and we are squaring it. We take our denominator and we are squaring it. So 2 to the third power is being squared. So that would be 2 to the 3 times 2 over 3 squared. That's also being squared. So we end up with 2 to the 6th power over 3 to the 4th power. And I'm okay with you leaving them like that. If you wanted to, you could multiply them all out, but I get it if you don't want to too. After all, this would be 27 over 64. They get big quickly with exponents. All right, I want you to try at least 3 more on this page. All right, try at least 3 more on this page. They're the same one. Oops. All right. There is some more practice right here, and I think that this is useful. I'm going to do this one with you guys. That way we can see using multiple of our rules together. So our first one, let's do power of a quotient. So for this one, we've got 2/3 and it's being squared. So that's really 2 squared over 3 squared. And then I'm going to end up multiplying that by 3a that is cubed and 2b that is cubed. Now I'm going to apply my power of a product rule. So this basically gets distributed, right? So we're going to have 2 squared times 3 cubed times a cubed over 3 squared times 2 cubed times b cubed. Now I'm going to rewrite that so I can see it a little easier, because right now my 2's and my 3's are all kind of scrambled up. So I'm going to write it in numerical order. So 2 squared times 3 cubed times a cubed over 2 cubed times 3 squared times b cubed. And remember, our quotient rule says I can subtract these. So this would become 2 to the 2 minus 3. Well, 2 minus 3. And then 3 to the 3 minus 2. And then we have a cubed over b cubed. 2 to the 2 minus 3 is really 2 to the negative 1. 3 to the 3 minus 2 is really 3 to the 1. And then we have an a cubed here over b cubed. And like I said, we will figure out how to simplify that negative 1. We like to have positive exponents, not negative, but for now, we're going to call that good. So I encourage you to try a couple more on this page. There are a couple more to try out, right? There are a couple more to try out. And to email me if you have any questions.